Okay, our quick look at the calendar. Last class we talked about graphing parabolas. Today we change gears yet again, talking about the quadratic formula. We're actually going to spend 2 days on the quadratic formula. So that's the plan. And again, a little ways away, but April 23rd is our next quest. Questions on the calendar. Okay, so on page 50, we'll start up here with number 1. It says, examine the following graphs, A, B, C, and D. And each of them is a parabola. And what we're going to do is state the number of x-intercepts and estimate the coordinates of the x-intercepts. So for the first one, x-intercepts, remember, are places where the graph hits the x-axis. So that first graph has 2 x-intercepts. And if we had to estimate the coordinates, how about the one on the left? Zero, -6. Everyone agrees? -6, 0. Okay, and then the other one, 1, 0. Okay, 60 seconds to fill in the other 3 graphs. You're counting the number of x-intercepts and you're estimating the coordinates. Okay, so let's come back together. The one that we did first had 2 x-intercepts. How about the graph B? Has just the 1, just barely touches the x-axis and then runs away. And then down here, graph C. It has 2, but these ones, it's harder to know exactly what the estimates are, right? We're just estimating these guys, or what the intercepts are. So I came up with -3.5 and 1.4, but it's just a guess. There's no way to know just looking at the graph. And then graph D is different than all the rest. How many x-intercepts? None, which is really problematic for us actually, because if we were trying to come up with the graph that looked like graph D, in order to find the vertex, remember we would have to find the 2 x-intercepts and then average them. But if we tried to find the x-intercepts, we wouldn't find any, so we would have no way to get to that vertex. No way at this moment. Soon we will. So, number 2, how many x-intercepts are possible for a parabola? What's the fewest number of x-intercepts you could have? You could have none. What's the biggest number you could have? 2, and you could also have 1. But that's it. You can never have any number besides those 3 numbers. So 0 or 1 or 2. Let's come down here to number 3, which takes a look at graph A again, same graph as we started with. So here now I'm finally giving you the equation. Y = x² + 5x - 6 is what I asked GeoGebra to graph here. So let's fill in the x-intercepts again. So it looks like they are still at -6, 0, and 1, 0. Okay, let's move on to the next question. Using the graph, identify the solutions to the equation 0 = x² + 5x - 6. I'm going to change that question just briefly. What if I said 5 equals? So the x² + 5x - 6 is exactly the same thing that we had up here. So in this case, we'd be saying, okay, we're really thinking that y is the number 5. So what would we do looking at that graph to solve this equation? Where would we go? Well, if you wanted to solve this algebraically, you would put it in standard form by making a 0. But we want to just use the graph. We don't want to do any algebra. So if we say that y is really played by the number 5, the role of y is played by the number 5, then we go over there to where y = 5, which is right up here. And what do I do from there to find solutions to my equation? You guys remember going left and right? So we go to the right until we hit the curve. And then? And straight down and we get like 1.4 or something like that. So you don't need to copy this because that's not the question I'm asking. But this is to remind us that we've done this before. And then are there any other solutions? We go to the left, and then straight down, negative 6.7. I don't know. Right. So we've done this before. So it's possible to solve certain equations looking at graphs. And the first step that we did was to go to y equals 5, because that was the number over here. Okay, so let's try to solve the equation that was given. Now it's a 0 equals. The first step is go to y equals what number on the graph? A moment ago it was going to y equals 5. Where are we going now? To y equals 0. It's not 5 anymore, it's the number 0. So we start by going to y equals 0. Now, it was easy for me to know that y equals 5 was up here. But where is y equals 0? Where is y equals 0 on the graph? Yeah, you're giving me the answers. You're one step ahead. How do I find y equals 0 on the graph? There's y equals 5. There's y equals 10. Where is y equals 0? Is on the x-axis. Yes? Okay. So we're really starting there on the x-axis. Used to be we started up at 5 and we went left and right. Now we're starting at 0 and we're going left and right. And we hit the graph in 2 points. And normally from wherever you hit the graph, you'd have to go down so you could find the x-axis. But we're already on the x-axis, so there's nowhere to go. So I think what Victor said before, negative 6 and 1, those are the answers to this equation. Those are the solutions to this equation. It's x equals negative 6 and x equals 1. So x equals negative 6 and x equals 1. And so we're going to make a really key observation. Now, this could be the first time you have ever seen this connection before. But here it is, and we will revisit this, I promise. Solutions to 0 equals something with x's, like 0 equals x squared plus 5x minus 6, correspond to x-intercepts of y equals whatever that same stuff with x's was. If you're looking at a graph and you're trying to solve the equation equals 0, you are looking for x-intercepts. So solutions to 0 equals ... x ... That's my way of saying some generic stuff with x in it. I don't want to be specific. But in our case, this 0 equals some stuff with x was this equation. 0 equals x squared plus 5x minus 6. So solutions to an equation equals 0 match up exactly with x-intercepts. Okay. So now let's see if we can go down to this last part. It says, how can we find these solutions algebraically? So I'm just giving you this highlighted equation. 0 equals x squared plus 5x minus 6. What's the first step for solving that kind of equation? Factor. Right? It's already in standard form with the 0 and in the right order with the x squared first. So we have to factor. I'm going to write 0 equals and then 2 sets of parentheses. Okay, in order to get x squared in the front, what do the first terms have to be in each parentheses? X and x, we've seen that 100 times. Is this the easy product sum or the harder box? Easy because? Yeah, x squared has nothing in front, right? So that makes it the easy product sum. Product and sum. So this is the miracle that happens, and some of you have already had the miracle, and for some of you it really feels like a miracle. We don't want two numbers whose product is negative 6 and whose sum is positive 5. Product is negative 6, sum is negative 5. Take 30 seconds to see if you can find those two magic numbers. Product is negative 6, sum is positive 5. Okay, so the two magic numbers are what, positive 6 and negative 1. So you can put them in either order in the parentheses, but that's where they go. And then finishing this, pretty straightforward. 0 equals a product of two things, so either the x plus 6 must have been 0, or the x minus 1 must have been 0, right? Split it up into the two pieces. Subtract 6 from the first equation, both sides. X equals -6. Add 1 to both sides on the other equation. X equals 1. We have our two answers. Does that agree with what we found on the x-intercepts? Yeah, it's exactly the same numbers as we saw from the picture, -6 and 1. Okay, so that's pretty old stuff right there. But let's move on to a tougher one. So here's graph C. And now finally I'm giving you the equation of graph C. It's this. Y equals x squared plus 2x minus 5. Now, can we know exactly what those x-intercepts are by looking at the equation? Or sorry, by looking at the picture? No, it looks like, -3.4 or maybe -3.5, but it's really hard to know. And in terms of trying to factor this guy, x, I want the product to be -5 and the sum to be +2. Can you guys find two numbers that do that? Multiply to -5 and add to 2. What are the only ways to get numbers to multiply to -5? 5 and 1? Yeah, 5 and -1 works. Did they add up to the right thing? Is this +2 in the middle? No. What's the other way to get a -5? We did 5 and -1. I think that's the same, but said in the other order. I want two different numbers. 1 and -5, right? But add those and you still don't get the magic +2 in the middle. So this just doesn't factor. So there are definitely solutions to the equation 0 equals x squared plus 2x minus 5. I can see them from the graph. I can estimate those two x-intercepts, but factoring just won't get us them. And so we need a more powerful technique, something we can use when factoring doesn't work. So here it is, number 5. We can't find the solutions to the quadratic equation 0 equals x squared plus 2x minus 5 by factoring. So how do we solve for x in a case like this? Enter the quadratic formula. So here it is, something I think many of you have seen already. A quadratic equation written in the form ax squared plus bx plus c equals 0 has the solutions, and then there's that formula. X equals -b plus or minus square root b squared minus 4ac all over 2a. Show of hands if you've seen that formula before. Fantastic. Keep your hands raised if you think you've already got that formula memorized. Anybody feel like they have it? Okay, so here's the good news. On the remaining quest and test and final, I will provide this formula at the top of the test, all right? So I don't need you to memorize this thing. That said, it turns out that you can sing the quadratic formula to the tune of Pop Goes the Weasel. You guys know that kid song? And there's some real cute videos on YouTube where you can see like 2-year-olds trying to do that. So if you want to memorize it and you need some help, you can sing it to Pop Goes the Weasel, and that might help. Okay, so let's see if we can jump down here to number 8. And we're going to solve 0 equals x squared plus 2x minus 5. That's the one that we couldn't factor a moment ago by using this brand new formula. So 3 steps. Anytime you want to use the quadratic formula, you use these 3 steps. If necessary, put the equation in standard form. That means 2 things. 0 is on one side, and that the equation is written in the right order. X squared first, x in the middle, no x at the end. You see that? Step 2, identify and write down the values for a, b, and c. Let's give it a shot. A equals, b equals, c equals. A is always the number touching x squared. What's the number touching x squared in our particular equation? It is 1. That's this one right here. B is always the number touching the x. What's the number touching the x? 2. That's this 2 right here. I circled the plus sign as well. Whatever sign is in front comes along with the number. And then finally, C is the number hanging out by itself. How much is C in our case? -5. That's good. Again, make sure you grab that sign right in front of the number. Questions on identifying A, B, and C? Great question. Let's come up with 2 quick examples. Boo, can you give us one where you're missing B or C? X squared -5. Okay, so A and B and C. How much is A? Still touching x squared. Still 1. B is always the number touching the x, but I don't see a number just touching a solitary x. Must be 0, right? The only way that there could be, the only way we could force an x to be in there is to slap a 0 in front of it. 0x, no, you don't need to write it, but you do need to acknowledge that B is 0. It's not 1, it's not anything other than 0. How much is C? -5 is good. Let's try another one. Boo, can you give us one missing a C term? +4x, and then nothing. Let's try that one. How much is A? 1. How much is B? 4. How much is C? 0. Good. So if you don't see a term there, you got to make sure you acknowledge that with a 0. Other common mistake that I see is sometimes people will grab the x and they'll say, oh, A is 1x squared. Like they'll grab the whole thing. A, B, and C are just numbers. The x's are built into the setup of this thing. Okay, good question. All right, step 3. Here's the hard part. Substitute these values into the quadratic formula and simplify your answer. Let's give that a shot. So here's, this one is the one with the process. Okay, so here's the formula, x equals -b plus minus all that stuff. So we're going to very carefully copy this thing and then do a lot of simplifying. Okay, -b. So I'm going to throw a negative sign in the front. How much was b for our example? These are the numbers in red now. It's 2. So we begin with a -2. -b. Plus or minus, it's a symbol that's part of the formula. So you just copy it every time. Then there's a big old square root. And you copy that every time as well. Then we do b squared. Now it's quite possible for you guys to do that in your head. How much is b squared? 4. But I don't think you should do it in your head, at least not until you're really comfortable with the quadratic formula. What I'm going to do is this. 2 squared. Also notice I put something else in there. What did I put in there? Parentheses. Because if this had been a -2, it's really easy to kind of lose sight of whether is -2 getting squared or is it just the 2 getting squared and then a negative in the front. So I'm throwing parentheses around that every time I write it. Okay, next thing in the formula, -4 times A times C. Yurka. It's +2. It's the whatever B was, which was a +2. Okay, -4 times A times C. -4 times, what was A? 1 times, what was C? -5. Notice I put dots in between them. Also notice I didn't try to do all this in my head. It's really easy to lose track of minus signs when you do too much in your head. So just write it all out very carefully. Take your time. Downstairs is 2 times A. 2 times 1. Okay. Questions on plugging into the quadratic formula? So far, so good? Okay, so now we're going to do some arithmetic. I won't say it's hard, but it's complicated as far as arithmetic goes. So copying the first part, -2 plus or minus square root of. Okay, 2 squared, you already told me, is 4. And we've got to subtract 4 times 1 times -5. What does that all become? Victor? Yeah. Yep. 4 minus 20 like this. Agree? Who? Yeah, it's going to be a plus because it's a subtract a negative 20. And so you're welcome to write 4 minus negative 20, and that's really showing all the details. I'm actually not going to show that level of detail. I'm just going to make it a plus. And all that I look for is how many negative signs do I see? I see a subtract, and I see another negative sign. So I'm going to treat those as two negative signs. I immediately write a plus because I know two negatives multiplied give a plus. All divided by, and then 2 times 1 is just 2. And I encourage you to just do this step by step in pieces, but every time you do it, it's going to get a little bit simpler, which is the goal. Continuing down here, negative 2 plus or minus the square root of, okay, that's easy, that's 24, divide by 2. Okay, so that answer is fairly clean, but it's our obligation to simplify as much as possible, and this one is not simplified at the moment. So I'm going to copy the negative 2 plus or minus square root of, and I'm going to copy the 2 downstairs. And then I'm going to remind us that we spent some time simplifying square roots. Is the square root of 24 anything nice? No. But is there a nice number that goes into 24? 8 does go in, but is 8 a nice number inside of a square root? No, we want to find a number inside the square root that will be nice. It's 4, right? 4 goes into 24. How many times? 6. Do you guys remember doing this? Factor the number into something nice, a perfect square, like 4, and then whatever's left over. Negative 2 plus or minus. The 4 comes outside of the square root and becomes 2. What's still inside? 6. All divided by 2. Okay, it is very tempting to cancel the 2's. In fact, it might have been tempting to cancel the 2's from the very beginning, like here and here. But we can't, at least not in the current form. So instead what we do, and again, this is something you have seen before, is we're going to split this complicated thing into 2 different fractions. So I got 2 fractions with a plus or minus in the middle. That 2 in the bottom is going to be in the bottom of each of my 2 fractions. 2 is underneath both parts. And all we do is take the 2 pieces upstairs that have the plus or minus in between and separate them onto our 2 fractions. So the first fraction, what's upstairs? Close, negative 2. Second fraction, 2 square root of 6. Do you guys remember doing that? And every time we do the quadratic formula and try to clean it up, this is going to be the technique, is to split it into 2 fractions. Because once it's in 2 fractions, then you're allowed to reduce the way that you normally would. So what happens when you reduce the first fraction? Negative 1 plus or minus, when we reduce the second fraction, square root of 6. All right, so I agree that the 2's cancel, but doesn't the 2 go into the 6 as well? Maybe square root of 3 up there? No, remember, you can't take a number outside a radical and mush it with a number inside a radical. They just don't go together at all. So the 2's cancel on the outside, and that's it. And we just get that. So negative 1 plus or minus the square root of 6 is our final reduced answer. Victor. We're just canceling them. Yurka. Say again? The 2 in the bottom, nothing outside a radical will go inside the radical. So the 2's can cancel because they're both outside. And then they're just gone completely, so all that's left is the square root of 6. Okay, that's the exact answer. We also need to make sure we can use a calculator to get the get decimal answers. So take a calculator out if you have one handy. And part of your goal after you practice this stuff from today is to make sure you know how to use your calculator. I don't know what calculator you have, but you got to make sure you know how to type in complicated things like this, because this is what the quadratic formula will spit out to you every time. So one other thing I guess I should say is that this thing here means -1 plus the square root of 6, and it also means -1 minus the square root of 6. So that plus or minus was just a little shorthand so that we didn't have to write two things every time. We just mush them together into one, and then at the very end I can say, okay, here's what the two answers really are. And so on the calculator I can type the first one, -1 plus the square root of 6. Maybe I can't. Oh, there it goes. All right, so 1.449. I think, what did it say to round to at the start of this problem? Nearest hundredth, so what is this? And 1.45, so that's this first one. It's approximately 1.45. And then we type in the other one. For me, I like to use second entry on this calculator so I don't have to retype the whole thing. All you're doing is changing a plus sign to a minus sign. So here we get -3.45. Now, if you have any issues typing stuff onto the calculator, I'll walk around in a little bit and you can ask me your questions, okay? Looking at the graph, do those two numbers agree with the x-intercepts? I think I had estimated 1.5 and -3.4 or something like that. So I was close, but not going to get all that accurate. But this is the way to get the most accuracy. These are the exact answers with the square root of 6. Victor. I'll look at it. One possibility is that you typed right there a subtraction sign, this guy, instead of the negative sign, which is at the bottom. Okay, so that's this one. Next page. We're going to skip over number 9. Let's jump to the hardest one here. It's number 10. Did that fix it? Good. Okay, so number 10 has fractions. You are welcome to do the entire quadratic formula with fractions, but if you're like me, you probably don't want to. So what we're going to do is clear all those fractions by multiplying everything by whatever denominator we see, which is a 3. So the very first thing I'm going to do is multiply the left-hand side by 3 and the right-hand side by 3. You guys agree that's a legal thing to do? Multiply both sides by the same number. And make sure you acknowledge that this 3 on the left is going to distribute to both terms. It's really common to write 2x squared as the first thing because you just put the 3 there because of the 7/3. But you got to recognize that the 2x squared is part of it. It gets the 3 as well. So what do we get when we distribute 6x squared plus, now that 3 comes in for the sole purpose of canceling the 3 in the 7/3. So what remains? 7x equals 3. There we go. That equation already looks a lot better to me. But there are several moments in that step where you can make a mistake. So you got to be really careful when you're clearing those fractions. All right, are we ready to pick off the values of A, B, and C? We got to move the 3 over first. It has to look like equals 0. Quadratic formula assumes that you've already got it in standard form. So move the stuff to the left. 6x squared plus 7x minus 3 equals 0 by subtracting 3 from both sides. Okay, let's grab the values of a, b, and c. How much is a? 6. Someone we haven't heard from. How much is b? 7. Somebody else we haven't heard from. How much is c? -3. All right, why don't you guys take 60 seconds with your neighbors, plug these things into the quadratic formula. It's there. And let's see how far you can get with simplifying. And we'll come back together before you start the group activity. All right, so after doing some simplifying, you should end up with this thing, -7 plus or minus the square root of 121 over 12. And then I saw a bunch of people split that into 2 fractions, which is a great idea because then you can reduce. Unfortunately, the 12 doesn't reduce with the 7, so we can't simplify at all. But one thing we do notice, and this rarely happens, is that 121, which is inside of the square root, is actually a nice number inside of the square root. 121 is up here on our list. So -7 plus or minus, how much is the square root of 121? It's 11. And then this guy is divided by 12. And the way to actually figure out what's going on here isn't so much to split it up in terms of 2 fractions, but it's to split it up in terms of that plus or minus. It really means -7 plus 11 over 12, or -7 minus 11 over 12. So I would split it, but not so much fraction-wise, but plus or minus-wise. And then we can just do these 2 calculations separately. -7 plus 11, that's 4. And it's divided by 12, and we reduce at this stage. 1/3. And then down here, -7 minus 11 is -18 over 12, which reduces to -3/2. And we have our 2 answers. Normally there'll be decimals, they'll be really messy with radicals still left in them, but in this case, they cleaned up and we just get 2 nice fractions. Okay, so I'll walk around and help with calculators. I can answer any questions that folks have on this one, but when you're feeling confident about this quadratic formula example, move on to the group activity where you will find 4 quadratic formula things. If you're having trouble with the calculator, don't just gloss over it. I'm expecting that some of you will lose points because you don't know how to use your calculator on the next quest. So today is a really good day to ask questions on how to type these complicated things into the calculator. Raise a flag if you get stuck.